theorem, kind of a continuation on Pascal's triangle. It's closely related to binomial expansion like we did yesterday. Saw a lot of submissions on Schoology that looked great. So it seems like you guys were really getting the hang of Pascal's triangle and figuring out the patterns, and hopefully we're understanding pretty well. Again, if you're not understanding something, send me a quick email. We'll set up a Zoom session. It might take 10 minutes, 15 minutes, and you and I can just talk through one-on-one the part that you're struggling with and go from there. Okay, so get your questions answered earlier rather than later so that you're clear on all these different topics. All right, so binomial theorem. We're going to start by talking about the factorial symbol. So in English class, you guys called this an exclamation point, right? This little guy right here. But in math class, it is not an exclamation point. It is now a factorial symbol. So we don't say n, like you're exclaiming it, like n, exclamation. That's not what we say. We say n factorial. And all that means is it's 1 times 2 times 3 times whatever up till you get to n. 0 factorial is always defined as 1. And so, for example, 3 factorial, usually we actually start with the number itself. 3 times 2 times 1, and we go down to 1. And so that would just be 6. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. And then 4 factorial is 4, 3, 2, 1. So as you notice, a lot of these are going to cancel out here. And so you can kind of use a shorter version way of just simplifying. And your answer would be 30. Okay, so that kind of idea. With this next one, it's a little bit bigger to do by hand, but you can use a calculator on these. So let me show you how the calculator works with factorial. So you should be able to have your calculator here. Let me show you where it is. Okay, so if I want to do 20 and then I want to get the factorial symbol up there, the place I'm going to go to do this is under Stat. So it's this button right here, Stat. I hit Stat. And then, oh, maybe I lied. Maybe it's not Stat. I totally lied. Hold on, not Stat. Quit. It's 20. Oh, let's go under Math. Aha, there it is. It's under Math. So I lied. Right over here, under the Math button. Go to Math, arrow over to Probability, because this is a probability topic. And it's number 4 right there. So number 4, it's that exclamation point. I hit enter, and there's 20 factorial. So a very large number. As you can see, that's standard deviation, right? But then I want to divide that by the quantity 8 factorial. Again, I'm going into Math prob times 12 factorial. And I hit enter. And that's my final answer. So that would have been one that would be pretty tricky to do by hand just because it was so big. You could have simplified it out a little and got some of the more simplified answers, but that's how I would do it on the calculator. Okay, so that's how you use the factorial button. Now these next examples, you obviously can't use your calculator because it's variables. And so what you'll do here is actually work these out by hand. So let's think about n plus 2 factorial. That means I would have n plus 2, and then I'd go 1 less than that, like, right? 3, 2, 1, 6, 5. You're always going 1 less. So 1 less than n plus 2 is just n plus 1. And 1 less than n plus 1, well, that's just n. And if I think about it, then it would just be n minus 1, n minus 2, etc., which is the same thing as saying n factorial. So really right here is going to be exactly the same as this denominator of n factorial, and I can cancel those two out. So what you're going to do is take the whatever one is bigger, and expand it down until you reach the smaller one, and then they're going to cancel out. And so now I'd just be left, and I could FOIL this, n squared plus 3n plus 2 would be my final answer there. And then this one, same idea. So I'll take the bigger one, n plus 1 factorial, and I'll count it down. So minus 1 would be n, keep counting down, n minus 1 factorial, which will cancel with the n minus 1 factorial on the top. And so my final answer would be 1 over n squared plus n. And we're, oops, sorry, you couldn't see that. Hold on, zoom out. 1 over n squared plus 1. Or sorry, n squared plus n. Okay, so that's just how you use a factorial symbol. Okay, so what does this have to do with this thing called the binomial theorem, which we're talking about? We're talking about what's called the binomial coefficient. Okay, and a binomial coefficient is used with this notation here. It looks like parentheses, and there's two numbers in there up and down, but it's not a fraction, right? There's no fraction bar. It's just two numbers. And the way we read this is a combination, and we read it n choose k. It's called a combination. And this is used in probability a lot when you're taking a combination of things. How many combinations can I have of that group of 10 students with 5 girls and 4, whatever it is, right? And you take a combination of those, right? So these are used in probability a lot. But it's also used when expanding these binomials and using Pascal's triangle. So I'll show you that connection here. So let n and k be non-negative integers with k is less than or equal to n. So k always has to be smaller or equal to. And this is what binomial coefficient means. So it's n choose k is just equal to, this is the definition, n factorial on the top over k factorial times n minus k factorial. Okay, so you could work this out, like, for example, what if I had you take, you know, I don't know, like 7 choose 3, right? And so that would just be 7 factorial, because that's on top. And then the bottom, it's k factorial, which would be 3 factorial, and then the difference, 7 minus 3 factorial. So then you would work this out, right? It'd be 7 factorial over 3 factorial times 4 factorial. In this case, you could work it out by hand. You could work it out right, this is how I'd work this one out, by hand, and just see what cancels here. 3 times 2 is 6, so I'd be left with 35. Would be that expression, 7 choose 3, the answer would be 35. So if it's just numbers, you can work them out. If it's variables, you would get a variable expression, right? So the cool thing is that these combinations, right, these binomial coefficients, if you take like the 7th row, right, of Pascal's triangle, and you do 7 choose 0, and then 7 choose 1, and then 7 choose 2, and 7 choose 3, all the way to 7 choose 7, those numbers are going to be the exact same as the coefficients in the 7th row. So that's what this means. The entries in the n plus first row of Pascal's triangle are just these binomial coefficients. So for example, find the binomial coefficients for the 4th row. It's technically the 5th row is what it really is. So what I'm saying is if I wanted to do a plus b to the 4th power, and I look at Pascal's triangle, we know we can go back. It's 1, 4, 6, 4, 1, right? I think that was what it was. 1, 4, 6, 4, 1. So that was the coefficients. Now watch, if you do binomial coefficients, so I would do it's 4, right? So do 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Now I can work all these out by hand by using this formula up here, right? So it's my formula. It's 4 factorial over 0 factorial times 4 minus 0 factorial. So when you work this out, 0 factorial is just 1. This is just 4 factorial. So 4 factorial divided by 4 factorial is just 1, right? And you can do each of these by hand. It'd be 4 factorial over 1 factorial times 4 minus 1 factorial. And when you work this out, I promise you, you're going to get 4, which matches the coefficients from Pascal's triangle. Sorry, that ran out of space. Okay, so when you work each of these out, it's going to match. Now, I'm going to show you how to do binomial coefficients on your calculator, because sometimes there are going to be bigger numbers that are hard to do. These ones are easy to do, right? By hand, I can do 2 times 2 times 4, right? And I can work this one out. 4 factorial is just 4 times 3, right? So I get 12 divided by 4, so I get 6 here. 4 times 3 times 2, sorry. 6, 4 times 3, 12, 24. That makes sense. 24 divided by 4. So it would give me 6, and it would work out. But sometimes you're going to have numbers that are a little bigger. So I want to show you how you can do these on your calculator. So on your calculator, again, it's that word combination. Combination in your calculator is a C. And so I'm going back up here where it said N choose K. So on your calculator, I think it says N. I think they replaced K with R for whatever reason. And it's a big C and then R. This is the button we're looking for. So I'll show you where it is. It's this button here, NCR. It's a little N in the front, then the big C in the middle, and the R. This, I think, is back in stat. That's what I was talking about, stat before. Calc. Tests. Nope. I guess it's back in math. Oh, I thought these were all in stat. I guess they're in math. So go to math. Oh yeah, back under probability. There it is. NCR. So it was right above where you got the factorial symbol. So under the math button, arrow over to probability, number 3, and you hit enter. And then on my calculator here, because it's a newer version, I can just fill in. So if I'm trying to do 4, choose 3, I'll put the 4 here, put the 3 here, hit enter, and it gives me that. Now if I'm trying to do 4, choose 4, I can just change that, and I get 1. And so indeed it matches, okay? So somebody say, well, this is a lot more work, right? It's a lot more work to go through and do this whole factorial thing, or even to plug that in my calculator and type it in. I can just do Pascal's triangle. Pascal's triangle is easy. I just do the pattern, and then I take the row, and then I'm good. Those are my coefficients. So the point of binomial theorem and why it's helpful is when you're doing larger expansions, right? So Pascal's triangle is great is for to the first power, second power, third power, fifth power, sixth power, seventh power, even 8th or 9th power, you can do Pascal's triangle. But if you're trying to expand something out to the 25th power, you don't want to use Pascal's triangle. That's going to take forever. And so that's why this binomial theorem is really helpful for ones that are longer and bigger to be able to find those terms. Okay, so I'm going to stop this video here and continue in part 2 on the back side.